Okay, welcome to another great video. I'm gonna look at some nonlinear functions. Actually, first let me just do. There was something I felt like I'd missed. Oh yeah, let's do mx plus b at the sliders. So let's say we just leave the gradient as 1. If I change the b, see if you can work out what will happen as I shift that. Okay, the gradient should stay the same, but this y-intercept should shift. So this whole line should just shift up and down. So watch, ta-da! See how the gradient stays exactly the same. So the angle, it's all of these lines are parallel to each other. Okay, I can change the angle, and all of these will be parallel. Change the angle. Now it's negative, so it's going down. Change the angle. Go over here. Change where it is. Okay. All right. Now let's do some nonlinear ones. So what is there? Quadratic. See if you know what the formula for a quadratic is. So you can do x squared. Let's just try that. That is called a parabola. Okay? It's very cool. Look how much it curves. And it actually goes up very fast. Faster than probably what you normally draw it as. But we mainly focus on this shape here. Just the way that it curves and goes forever. And you can look at some of the values. So 0, 0. Go across 1, it goes up 1. Because 1 squared is 1. 2 squared is 4. 3 squared is already 9, which is much higher. 4 squared is 16, so it really starts to accelerate. Just a little tip, by the way, with all of these functions, the best way to graph it is a table of values, to just look at some values. Let's try generalizing this a bit. Like, what happens if I add 1 here? What do you think will happen? All that does is it adds 1 to every single value, so the whole thing should shift up by 1. And in fact, I can make it a C, add a slider. Okay, so now I can shift it up, down, 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 to any value. And whatever that number is, that's where it'll go. So minus 5.1, that's where it is. Minus 5.1. Boom. Okay, hang on. And let's add an A here. Let's make C a bit bigger. Add a slider. So if there's a number in front of the x squared, what does it do? If it's bigger, we're multiplying it. That just sort of means it gets bigger faster. It won't change the y-intercept though. So you should see this thing get thinner as this goes up. Okay, look at that, pointy. And then this will get much wider. If you get to 0, you actually start, yeah, it'll go down anyway. And yeah, so if it's 0, then you're just basically getting rid of the x squared. You just get constant. Okay, hope that makes a little bit of sense. This is just a way to play around with it. See, it's very flat. But remember, if you want to find the values, you just sub these numbers in. You'll probably get nicer ones. Let's just do a quick practice one. Let's say you had 2x squared minus 3. Okay, get rid of these. Now, let's not worry about what it looks like yet. How are you going to figure it out? So, if x is 0, you should notice that y will be, that part will be 0, so it will be minus 3. So let's do the point 0, minus 3. Did it work? Yep, there. Then I can do the point. What about x equals 1? So 1 squared is just 1, times it by 2, and so that's 2, take away 3 is minus 1. So 1, minus 1. Okay, and you should notice for minus 1, if you put in minus 1 here, you square it, you still get 1. You get the same. Parabolas are often symmetrical. So you have the mirror image. Okay, what about 2? 2 squared is 4. Times that by 2, you get 8. Minus 3 is 5. So 2, 5. And it's going to be the same on the other side. Let's see. Ta-da! So what you would do, you would just get these points. Let's get rid of that. You'd see that, and then you have to be smart enough to connect it. You can also do fractions. So if you did a half, let's just try a half squared is a quarter, double it, you get a half minus 3. I'm just demonstrating it. That's what I got. You get that point. And the same on this side. That point. That starts to give you more of a picture. Okay? Anyway, let's get rid of all these. Okay, let's do... So that's a quadratic. What about a cubic? So it has x cubed instead. And it looks pretty funky. It's similar to, if you just look at this side, like that, it's a lot like a parabola. Okay? But the only thing is it's actually a little bit flatter here, and it's a little bit steeper. Because notice, if x is less than 1, if you've got a number less than 1 and you cube it, timesing a fraction by itself, by a fraction, makes it smaller. So it actually tends to be smaller here. But then it starts taking off and it gets bigger, bigger, bigger. But negatives, when you cube them, you still have a negative. So that's why it sort of flattens and then curves again. Let's just do x squared with it. So yeah, you'll notice they're equal at 1, because 1 squared is 1, 1 cubed is 1, but the cube is faster. Cubic starts getting much, much faster, and the gap will get bigger and bigger, basically. But here, in between 0 and 1, the cubic is actually smaller, because if you keep timesing a number by itself, a fraction, like half of a half of a half, it gets smaller. Anyway, okay, like just to continue that pattern, actually, you don't need to know, this is called a quartic. So instead of a quadratic, a quartic, x to the power of 4. See, it's even more exaggerated. Fractions get even smaller, but then once it crosses 1, it's even faster than a cubic. So we could do a simple example. 2 to the power of 4 means 2 times 2 times 2 times 2, which is 16, it turns out. So if I go up to 16, 16, you should see the blue one should go right through 16 there. Whereas 2 cubed is only 8. So the cubic will only go through 8 there. And 2 squared is only 4. Okay? But anyway. And quartic, because it's an even power, it's symmetrical again. So negatives to the power of 4 are still positive. Okay? Anyway, let's look at just the cubic. What if I plus 1? So it just shifts up the whole thing. If I take away 3, it shifts the whole thing down by 3. Okay? I'm going to leave it there for now, so I'm worried that it'll die if I do too long.